Okay, so the scientific revolution and enlightenment, the word revolution is going to mean we're going to see a lot of change in this unit. So what we need to do is kind of do a recap, a refresh, where we started the year and look at the world as it was in the medieval view, and then we'll move to what all of these big changes were. So the medieval view of the world, if you'll remember, it was primarily religious and theological, kind of like everyone was looking through Jesus-colored glasses. Everything was about Jesus. So if this happened, it's because of Jesus. This is everything. The Bible was looked to for the answers for everything. We just finished discussing that political theory was based on the divine right of kings, and so we're coming through that time period here. So that hasn't changed yet. We'll see that change with the Enlightenment. Society is largely governed by the church views, traditions, and practices. So as we've discussed, everything was focused around the church. Superstition have played a major role in the lives of people. We're going to start to see that change with the scientific revolution. And there hadn't been a lot of scientific thought in the early 16th century. It was still really based on medieval ideas. So we're going to see a huge shift here. Views about the universe were largely influenced by the ancient ideas of Aristotle still. Remember, humanism in the Renaissance brought us back to our Greeks. And so that view is still held. So we have some pretty old ideas going on here. And one of those being the geocentric view held that the Earth was the center of a static, motionless universe, that there are 10 spheres around the Earth, geocentric, of course, meaning the Earth-centered. At this time, there were only 5 planets, but we'll see that 2 more spheres will be added during this Middle Ages, and then what they thought was beyond these spheres was heaven. So you can see from this diagram, this is the Aristotelian view of the universe. So the Earth would be at the center, and then there's all of these spheres around it. And then, of course, outside of it would then be heaven, or where God is. And then there were 4 essences: earth, air, fire, and water. And then a 5th essence, which was perfect, which is thinking about the heavens again, which was a quintessence. And so this is the view that's been held for a really long time. We're going to start to see challenges to this during the scientific revolution. But if you remember, one of the works we looked at, Dante's Inferno, is actually going to replicate or reflect this Aristotelian view as well. So in Dante's Inferno, one of our first books that we talked about in the vernacular reflected Aristotle's physics. 10 spheres surround a spherical, motionless Earth. Hell was at Earth's center. Heaven was out at the edge. And so you can see the Aristotelian view reflected as well in Dante's work. And so we know that there's going to be a big change, and let's talk about the causes first, because that's what APs focus on: causes, turning points, and then the effects. So the medieval universities are really going to provide the framework of which the scientific revolution is going to grow out of. By 1300, philosophy will become an accepted discipline, addition to law, medicine, and theology. And these medieval philosophers are going to develop a degree of independence from theologians and a sense of free inquiry, meaning they're going to kind of separate themselves from that all-Jesus view that was held in the 14th and 15th century. And then we're going to see that leading universities are going to establish new professorships of mathematics, astronomy, and physics, or natural philosophy within their departments of philosophy. So we start to see this edge towards the sciences rather than theology, because during the Middle Ages, science had been essentially a branch of theology, so it was all based on religion. We're going to start to see that separate as a cause of the scientific revolution. In addition to that, we also have the Renaissance stimulating science by rediscovering the ancient mathematics, and so that's that humanistic trait, like, oh, let's look back to the math and let's rediscover it and see what changes need to be made. Renaissance patronage was often scientific as well as artistic and humanistic, so going back to that patronage of the Renaissance. And then our third cause here is the explorations that we've seen. In this age of exploration that we talked about, they're going to have to problem solve. Navigational problems on sea voyages in the age of overseas expansion is going to create a need to solve navigation problems, a need for scientific advances such as new instruments of the telescope, the barometer, the thermometer, the pendulum clock, the microscope, the air pump. We'll see Gresham College in England, where scientists will work closely with top officials in the Royal Navy and leading merchants and shipbuilders, which will become a main center of scientific activity during the first half of the 17th century. And this is where we're going to start to see scientific methodology created, and we'll get into that in more detail later when we talk about Bacon and empirical experimental research, and Descartes with deductive reasoning. And so what we're going to see is the scientific revolution is going to become the major cause of the new world view of the 17th and 18th century. Because of this, secularism is going to emerge, and many educated people are going to become openly hostile to religion. So we're going to start to see some anti-religion as well as continued religious thought during this time period. And the revolution in learning is going to become a major foundation in Western society. And this is where we really start to set up the grandness of Western society and learning. And so we need to recap just a little bit the 16th century and this transition from the Middle Ages to the 17th, 18th centuries where we are heading on Wednesday. And so it's worth noting here that you need to know how these individuals changed the world, not really the details of the science. This is AP Euro. You're not going to be really questioned or quizzed or tested about the science, but how they changed the world. But you will need to know a little bit of background knowledge on how this science is new and different. So our first individual is Nicholas Copernicus, 1473 to 1543. He was a cleric, so meaning he was a priest, and he is going to begin to attack the Aristotelian view or the geocentric view of the universe. It's worth to note here that he wasn't like openly trying to challenge the church. I mean, he was religious. He was really just looking to try to explain God's works for creation, to understand the universe and the heavens. He's going to be actually kind of scared to publish his work because he fears a backlash by the scientific community, and he's actually going to dedicate his work or his book to Pope Paul III. Because he did not intend for his theories to challenge the church doctrine. He just really wanted to explain God's work. His work is called On the Revolutions of Heavenly Spheres and will actually be published in 1543. And he is going to promote in this work the heliocentric view of the universe. So this heliocentric view is going to argue that the Earth revolved around the Sun and that the Sun was the center of the universe. It stated that the stars did not move, although the apparent movement of the stars was the result of Earth's rotation. The universe now seemed enormous, perhaps infinite. And a major anomaly in his theory is the retrograde motion of planets relative to the Earth's position was remedied by the false premise of epicycles. And it directly challenged Ptolemy's 2nd century AD view of a geocentric universe. But more importantly, what it seemed to do is it seemed to challenge the Bible's book of Genesis that also put forth a geocentric view in books such as Joshua, where they state that like the sun, God stops the sun, and then when he's happy again starts the sun moving. So what is unmovable, it seems, is the earth, whereas the sun is the movable part. So it challenges how people had been interpreting the Bible. So the religious reaction to these seemingly challenges to the book of Genesis is that Martin Luther and John Calvin are going to actually condemn Copernicus' theory. They're going to point to biblical passages supporting the medieval view, such as, so the sun stood still and the moon stopped till the nation avenged itself on its enemies, as is written in the book of Jashar. The sun stopped in the middle of the sky and delayed going down about a full day. So here it shows that the earth is immovable and the sun is movable by God. There's also in Psalms and Corinthians, the world is sound and firm, the earth is on its foundation and can't be moved. All kinds of biblical passages that are literally translated. So if you think of Luther, he looks only at the Bible, and his interpretation of the Bible is that literally the earth cannot be moved. And so he's going to think Copernicus is crazy. Like, look at this. Like, you can tell from the Bible that the earth does not go round and round. And so the Catholic reaction, however, is initially less forceful because unlike Protestants, they aren't as literal in the view. They always didn't interpret the Bible literally. But because this change is going to then ultimately challenge their view, by 1616, the Catholic Church is going to proclaim the Copernican theory as false and persecute those who advanced his views, examples of which are Galileo, which we'll get to here in just a little bit. Okay, so our next guy, Tycho Brahe, becomes Europe's leading astronomer in the late 16th century. He's Danish, so he's from Denmark. He builds the best observatory in Europe. You can see it in the upper right-hand corner of the screen. And he collected massive data on his observations of the universe. So he has like 20 years of meticulous study. So massive amounts of data. Every night he's looking at the universe, and this moved here and that moved there, and I wonder why that happened. The data is going to become a cornerstone of astronomy for centuries. He has two problems, however. First problem, the math of this time period couldn't interpret his data yet. It will be able to be interpreted coming up, but not yet. So he has all this data, but there's not the math to keep up with his data. And then a second problem, just kind of a little FYI informative little fact, it proves that you can be smart but not make smart decisions. He actually loses part of his nose in a duel when he is 20 years old after a night of heavy drinking. And this is also going to lead him into a side interest of alchemy, which means like what you can turn like gold and silver and metals into. And he has a gold or silver replacement nose. But then what they also found out in 1901 when they dug up his body, he had a green ring around his nose, which also means that he may have had a copper replacement nose as well because, copper leaves a green ring. So it's a little side note there. Two problems, one that has to do with his research and one that just has to do with being young and not making the best decision. His data is later going to prove Copernicus's theory, but not yet because the math can't keep up. Ironically, Brahe did not accept the Copernican theory. He believed that while the planets all revolved around the sun actually revolved around the Earth. So because his data can't be interpreted, he doesn't even have his data interpreted quite correctly. But our next guy, Brahe's assistant, Johannes Kepler, 1571 to 1630, is going to make some advancements. And so Kepler, Brahe's assistant, is going to be the first great Protestant scientist. It said that Brahe said to him right before his death, "Let me to have not lived in vain." And so Kepler, let all this data I did that can't be figured out yet just, die with me. And so Kepler is going to actually, since he's a mathematician, he is going to mathematically prove the Copernican theory with Brahe's data and also develop 3 laws of planetary motion. Some of these are the orbits of planets are elliptical, so not circular, which you probably learned about in like the 3rd grade. Planets do not move at uniform speed while in their orbits, that they all kind of move at different speeds. The time it takes for a planet to orbit the sun is directly based on its distance from the sun. So the closer the planet to the sun, such as Mercury and Venus, the faster its orbit. And so these are just a couple of the laws that Kepler put in motion. That brings us out of the 16th century and into the 17th century with Galileo Galilei. So Galileo is a Florentine or from Florence, and he is going to develop the laws of motion. He is going to actually use the experimental method with controlled experiments. So it's actually not formalized yet, but he's going to stop like the speculating, like I think this might happen, and actually have experiments. His acceleration experiment is going to show that gravity was a universal force, or what he thinks gravity was a universal force that produced uniform acceleration, and that all falling objects descend with equal velocity regardless of their weight. His law of inertia is going to say that an object that is in motion remains in motion until it is stopped by some external force. Should sound familiar to you from physics. He is going to then state that rest is not the natural state of things. The natural state is to be movement until something acts upon something that's moving to stop it. And he's actually going to validate Copernicus's heliocentric view with the aid of a telescope instead of math. He was actually the first to use the telescope as a scientific instrument. He built one himself. He is going to demonstrate that the moon and other planets were not perfectly round like a crystal sphere, which had been the medieval view. And he is going to also discover the 4 moons of Jupiter, thus resulting in the notion that Jupiter was embedded in an impenetrable crystal sphere. And the really relevance of this is Galileo's findings are actually going to become controversial in Catholic countries because his view is challenging the view of the church. So while it is controversial in Catholic countries, his views are actually going to be largely supported in Protestant Northern Europe, where reformers have questioned Catholic doctrine. So they're like, ooh, a scientific proof that the Catholic Church is wrong. But the Catholic Church in 1616 is going to declare Copernican theory to be heretical. So not Galileo yet. They're going to say, hey, that Copernican guy, he's crazy. But in 1632, the Pope is actually going to ask Galileo to publish a work. It's called The Dialogue Concerning the Two Chief World Systems. So the two chief world systems would be the Aristotelian view and the Copernicus view. And so the Pope had asked him to write it just to present both views, but not to take a side. But after it's published, they feel as if he is taking a side, and they're going to get mad at him. And in 1633, the Inquisition of Pope Urban VII is going to force Galileo to retract his support of the Copernican theory. It's kind of like the Diet of Worms with Luther, where it's like, no, you take that back, it's against the church. And I think the difference here is that Galileo's like 68 years old. He's really old. They're threatening him with torture, and he's like, whatever, I recant. And he will then spend, instead of being killed for being a heretic or tortured, he's going to remain under house arrest for the rest of his life until his death. So Francis Bacon, 1561 to 1626, is going to formalize the empirical method or empiricism that had already been used by Brahe and Galileo. It had been informalized, it had been used, they'd experimented, Brahe and Galileo, but Bacon's really going to go, how do we know things? And that's based on experience and evidence, and that there's an inductive method for scientific experimentation, which should sound familiar to you from science class. You're going to begin with inductive observation, then you're going to form the hypothesis about what you think is going to happen, then you conduct experiments to see what really happens, and then organize the data. And he'd say you renounce notions and begin to form an acquaintance with things. So it's really all about this experience and evidence and not speculating. So the inductive method of Bacon is going to couple with Descartes, which is our next scientist we'll talk about, deductive reason, and will form the backbone of the modern scientific method, which is why it sounds so familiar to you, to form that hypothesis, to conduct experiments, to organize the data, research the data. Okay, so René Descartes is French, 1596 to 1650, and his work is called The Discourse on Method, and he is going to advocate the use of deductive reasoning. So that's easy to remember. You have inductive with Bacon, but deductive, Descartes, for René Descartes. He is going to say then logic is the authority for deductive reasoning. His proof depended on logic alone. So he would say, here's an example of a deductive proof. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. He's going to say you don't have to do an experiment or wait for Socrates to die to realize he's mortal. So a proof is just a logical step followed by a logical step followed by a logical step. His most famous is his employment of deductive reasoning to prove his existence. Cognito ergo sum. I think, therefore I am. And so since he can think, that proves that he is. And so logic being this authority, logic has to follow logic. So wherein the inductive method is evidence and experiment, the deductive method is all about logic. He believed that science must start with clear and incontrovertible facts, and you must subdivide each problem into as many parts as necessary using a step-by-step logical sequence. He is also going to be the guy that demonstrates the relationship between algebra and geometry and developed analytical geometry, but he is also known for what is known as Cartesian dualism. So Descartes, Cartesian, and then dualism mean two, and this is because he believes all existence can be divided into two things. So down at the bottom here, into spiritual and material. So like spiritual be like the mind and material be the body, and he believes that they are two different things. So the spiritual or the mind can only be examined through deductive reasoning or logic, those proofs that he's using. And the material or the body is subject to the experimental method or the inductive method because it's material, so you need to test it with experiments. He does believe there's a God. He uses this dualism in his proofs, the deductive reasonings. You can't let's put God under a microscope, but you can use deductive logic, or he would say you could. He would start with his proof, I exist. I have in my mind the idea of a perfect being, which is God, and then therefore, since that idea of a perfect being could only be put there by a perfect being, therefore a perfect being exists. So logic following logic following logic, and that's Descartes. Okay, so the modern scientific method is just these two things put together, deductive reasoning and inductive reasoning. So the inductive method of Bacon plus the deductive method of Descartes equals doing all of it at once. You're going to experiment and incorporate logic, and so that's the modern day scientific method. And so next is Sir Isaac Newton, whom some would say is the most important of these individuals. But he is going to take all of it and put it into one understandable view of the universe. So he is going to incorporate the astronomy of Copernicus and Kepler with the physics of Galileo into an overarching theory explaining order and design to the entire universe. He was, for doing something this huge, pretty humble. He is quoted as saying, "If I have seen further than others, it is by standing upon the shoulders of giants." So he's just recognizing that he's taking a lot of other people's work and putting it together. So pretty humble with everything he did. And so some of the things that he did do, let's look at his principle of universal gravitation, which is just encompassed in a work called Mathematical Principles of Natural Philosophy, or better known popularly as Principia. And so after 18 months locked away straight working on physics, he's going to give us the work Mathematical Principles of Natural Philosophy in 1687, better known as Principia, perhaps the greatest book on science ever written. You get to remember the story of the apple hitting him on the head, and it's in this work that he's going to give us some of the things you probably are most familiar with about Newton, natural laws of motion. So these natural laws of motion or gravitation are evident in the movement of heavenly bodies and earthly objects. Newton is going to develop a set of mathematical principles to explain motion. He is then going to go even further to talk about the attraction, or what he would call gravity, in the universe. He's going to say everybody in the universe attracts every other body in the universe in a precise mathematical relationship, equaling what he would call gravity. He's also going to say since these natural laws are unchangeable and predictable, God's active participation in the natural world is not needed to explain the forces of nature. He believes in God. He just believes that God created the universe with all these natural laws in place, so he doesn't have to jump in all the time to do anything. These are just natural laws. They're unchangeable. They're always present. He is a Christian, but his views are going to be used later by other people as we get into the Enlightenment to create what is known as deism, or this view of God. And so we're going to see this come about. But he was a Christian. This directly challenged medieval beliefs, and this view will be important to us as we move on because of the importance of deism in the Enlightenment. He's also going to be credited with inventing calculus, although Leibniz is also going to claim to have done so. So it's thought that maybe simultaneously and separately they both created it. But that's here or there who had it first, and maybe it got out. And so let's do a mnemonic memory device really quickly for the scientific revolution who we've covered, and then we just have a couple short more to get done here. So to remember the scientists of the scientific revolution in the 16th and 17th century, you can remember Kopp, Spring, Kids, Great Big Donuts Now, Copernicus, Brahe, Kepler, Galileo, Bacon, Descartes, and Newton would be your 16th and 17th centuries. And if you could pop some fact in about how they changed things along the way, you'd be great on an FRQ on how the scientific revolution transformed between the 16th and 17th centuries. Okay, so sorry, slide went there for a second. So there will be some changes to anatomy and physiology. Scientists are going to begin challenging Greco-Roman medical views, especially those of the Roman physician Galen in the 2nd century AD. Vesalius is going to give us the structure of the human body in 1543, and he's going to renew and modernize the study of human anatomy. Going to start cutting into people to figure some things out, which will also lead to improvements with our next individual here, Mr. William Harvey. So William Harvey, 1578 to 1657, is going to give us On the Movement of the Heart and Blood in 1628, and this is going to explain how blood was pumped by the heart and circulated throughout the body. So we take for granted that we know how all this works now, but really all of this is coming to the surface at this time with that inductive deductive reasoning. So Anton van Leeuwenhoek is 1632 to 1723, and he is considered the father of microscopy. He developed powerful microscopes. He's the first to see and write about bacteria, yeast, plants, living organisms in a drop of water, and the circulation of blood, corpuscles, and capillaries. So all of this due to the microscope and its use. And so out of all of this, science is going to become royal scientific societies. Governments and divine right monarchs are going to encourage scientific inquiry as a means to further the prestige of the state and remain at the cutting edge of technology, which gave them power. Scientific societies are going to create a means by which scientists could communicate with other scientists internationally, and this is going to help forge an international scientific community. The Royal Society in England was perhaps the most successful and prestigious of these scientific societies and was founded in 1660. Other royal societies were created in Naples, France, Prussia by Frederick I, and Russia by Peter the Great. Louis XIV, there's a painting I think I included here. Yeah, here it is, of Louis XIV visiting his Royal Society. But what the real impact and the importance of why we're talking about this is the impact of the scientific revolution on society is it's going to lead directly to our next topic, the Enlightenment of the 18th century. It's also going to create improvements in exploration. We're going to see the spirit of experimentation is going to help accelerate at the agricultural revolution, which we're going to see coming up very shortly, and industrialization of the 18th century. We're going to see improvements in medical knowledge are going to help improve the quality of life later. So not now, it's going to take a while, but in the 19th and 20th century, we will see much better quality of life because of this science. We're going to see reduced support for those witch hunts by discrediting superstition and witchcraft as fallacies. So we'll see a decline in that due to this inductive and deductive reasoning. And just something to note here that science and religion, we think about the controversies or conflicts that have been had like between creationism and evolutionism. In more modern times, but there's not really an attempt in the 17th and 18th centuries to secularize science. They won't come into acute conflict until the 19th and 20th century because scientists believed they were studying and analyzing God's creation. Remember, it's just like Descartes is just saying like, oh, like God is there and he must be, in my mind and I can follow this logical theorem. To go through there, Newton is saying that God created the earth with all of these natural laws, and so they just think they're studying God's creation. Universal agreement among scientists and philosophers regarding the supernatural origin of the universe existed in this time, and debates centered on the extent to which God continued to be involved in his creation. So is he there every day making things move, or is it like Newton said, where he just set everything up with these perfect laws and just took and stepped back? We won't see real acute conflicts until the 19th and 20th century. I mean, and even some of those are coming to the end now. With Pope Francis just said evolution and creation can cooperate together. So there's, maybe going to be an easement of these tensions moving forward. And so, let's see. We're going to see the Protestant countries become the leaders of scientific revolution, especially England, which is going to play a huge part in agricultural revolution and industrialism starting there. But we'll get to all of that after we talk about the Enlightenment, enlightened despots, and the revolutionary age with what the Enlightenment is going to do to France, namely as we get to the French Revolution.